The pricing system in VentumPrint is implemented as a calculator. Numerous factors are considered, summed up, multiplied by coefficients, dependencies are applied, and arithmetic operations are performed. The result of these calculations is the total cost of the print run. Let's examine how this mechanism works. In the simplest case, if there are no coefficients or additional options that affect the final price, the price calculation can be visualized as a linear graph. If we add quantity-based price dependency and use the corresponding coefficient, the pricing graph changes. It takes the form of a function, and its representation becomes a curve instead of a straight line. This type of graph accurately reflects real-world production conditions in a printing company. However, in practice, the price of a product is not determined by a calculator, nor by first cost, nor by a technologist or even the director. The market determines the product price. If the market allows the sale of a print run, for example, at a price of 100 euros, there is no sense in offering it for 50 euros. If we set a selling price of 50 euros for a product, but there are strong players on the market who have already established a benchmark of 30 euros for a similar product, unfortunately, we will not be able to sell our product in the desired quantity at 50 euros. We must then make a strategic decision, either not to enter the market with this product at all, or to adjust the price to match market expectations. Often, such indicative market prices do not apply to all print run sizes or product dimensions, but to certain values that users use to compare printing companies, whether they are expensive or affordable. Examples of such indicative prices include the price for 100 business cards or the price for 1,000 A4 flyers. Let's assume the market has established a price of 20 euros for 1,000 A4 flyers. Available print runs are 100, 300, 500, 1,000, 5,000, and 10,000 units. But it is the price for 1,000 units that is actively advertised by competitors and perceived as the reference. What will the pricing graph look like in this case? Print run 100 units, 5 euros. 500 units, 10 euros. 700 units, 20 euros. And 1,000 units, 30 euros. Our prices align with market rates for all print runs except the 1,000 unit run. Competitors offer 20 euros for an equivalent run, and we offer 30 euros. The first intuitive solution is to manually reduce the markup. However, this will lower prices across all runs, negatively affecting profitability. Alternatively, we could change the quantity-based coefficient, but this would lead to unnatural price jumps. For example, 1,100 units might end up costing less than 700 units. The correct solution is to reduce the price specifically for the 1,000 unit run. The price graph will then show a localized dip at 1,000 units to 20 euros, while preserving proper profitability for all other quantities. This indicative 20 euro price that users expect can be set as the initial configuration of the website page, as shown in the previous video. Let's perform this task technically. Previously, pricing was often implemented using a tabular method, where each combination of parameters, such as size and quantity, had a separate cell with a fixed price. Imagine that we used such a technologist's pricing table to fill in all product prices. However, the commercial director requests a price of 20 euros for 1,000 A4 flyers, in line with competitor pricing. With the tabular method, this would be very simple. Just update the value in the corresponding cell. But the tabular method is very labor-intensive to populate and maintain. With a large number of options, the number of tables increases and all must be interlinked. This results in a vast amount of data. Any change in an option, format, or quantity requires reviewing all values in the tables. In such cases, a linear calculator is indeed more convenient. It automatically calculates the cost based on administrator-defined parameters and dependencies. However, the tabular method has an important advantage: the ability to manually set an arbitrary price for a specific value. For example, you can set the price for a 1000 unit print run not at 30 euros but at 20 euros by simply modifying the value in the relevant table cell. The same approach can be used for other parameters, for instance, paper type. Suppose that, based on linear calculation, the price for 150-gram paper turns out to be higher than that of competitors. If the market price for this paper type is significantly lower, it makes sense to set a fixed price for this paper type to remain competitive. In this case, the linear pricing graph dips at the required value, allowing prices to be adjusted to market realities without breaking the overall calculation structure. So how can we influence the price at a specific point using a linear calculator? In VentumPrint, we apply a hybrid calculation method based on linear pricing, while also featuring functionality that incorporates the advantages of the tabular system. Let's explore this hybrid method through an abstract example. On the website, a 50 by 50 mm flyer with a print run of 100 units costs 25 euros. Competitors offer the same product for 15 euros. Prices for other print runs are comparable. In a tabular system, we would simply modify the value in the appropriate cell. In VentumPrint, we can achieve the same result more flexibly via the Fixed Prices section, which is a modern equivalent of the tabular method implemented in a more convenient and manageable format. Click Add Fixed Price. In the calculator, the price for 100 units is shown as 25 euros, same as on the front end. We manually enter the new fixed price in this field, 15 euros. Save the settings and check the website. The fixed price is displayed as 15 euros. In this way, we achieve the desired result without relying on a cumbersome tabular system that is difficult to keep up to date. You can create an unlimited number of fixed prices, analogous to cells in traditional pricing tables. Fixed prices apply not only to print run values, but also to any parameters or their combinations. For example, there is a 50 by 50 mm flyer with a print run of 10 and paper type 200 grams. According to calculator settings, the price for this configuration is 12.50 euros. For some reason, we need the price to be 10 euros. Let's set a fixed price of 10 euros. Save it, go to the website and select the specified values: flyer 50 by 50 mm, print run 10, and paper type 200 grams. The displayed price is correct, 10 euros. Companies accustomed to the tabular calculation method can build entire arrays of fixed value data here.